EES, which is pronounced EASE, is an acronym for Engineering Equation Solver. EASE provides property information for many different substances, and most of these are pure fluids that are modeled either using a complete equation of state or using some simpler model like the incompressible substance model or the ideal gas model. The fluid NH3H2O is a model of ammonia-water mixtures, and these are commonly used in absorption cycles. The properties of ammonia-water mixtures are available in the subcooled, saturated, and superheated condition, and both the thermodynamic and transport properties are available. Since NH3H2O is a mixture, its implementation differs somewhat from that for the pure substances. So first, it's going to require 3 independent properties to fix the state rather than the usual 2. Second, in addition to the familiar property functions that are listed here, like enthalpy and pressure and temperature, there is a new function called mass fraction that will return the mass fraction of ammonia in the mixture. And finally, there are some differences in the property designators. So while most of the property designators for NH3H2O, which are listed here, are familiar, so for example T equals is temperature and P equals is pressure, however, the property designator for quality is Q equals rather than the typical X equals. The property designator X equal is reserved for mass fraction. So X equal indicates that I'm going to give you a specific mass fraction of ammonia, whereas Q equals indicates that I'm going to give you the quality. Here we can determine the properties of an ammonia-water mixture that is 50% ammonia by mass at a specific temperature and pressure, 10 degrees Celsius and 1 megapascal. So as usual, we have to set the unit system before we use any property functions. And here we're going to use the $unit system directive to do this. Solving indicates that the specific enthalpy is minus 194.8 kilojoules per kilogram. The conductivity is 0.4791 watt per meter Kelvin. And the viscosity is 0.001294 Pascal seconds. The value of quality that's been returned is minus 0.001. And what that indicates is that this particular state is a subcooled liquid. So we can't, for this state, determine the surface tension. So if we tried here using the function surface tension, you can see that you end up getting an error, and that's because you can only get surface tension for a saturated solution. The thermodynamic and transport property data for the fluid NH3H2O are based on the references that are listed here. You notice that the thermodynamic properties provided by the fluid NH3H2O have a different reference state than either of the pure fluids, water or ammonia, and therefore properties like specific enthalpy or entropy or internal energy that are obtained using NH3H2O with 100% mass fraction of ammonia will not match those obtained using the pure fluid ammonia. So for example here, if I change the mass fraction to 1, I will not get the same enthalpy using the pure fluid ammonia if I call the enthalpy function. And similarly, if I were to change the mass fraction to 0, I wouldn't match up with the enthalpy of the pure fluid water. And as a result, it's important that if you're using ammonia-water mixtures in a cycle, then you need to use the fluid NH3H2O throughout your cycle model, even if in some places you have nearly pure ammonia or nearly pure water. This is one of a series of tutorials that is meant to describe the operation of the EASE software. To get more information about EASE, obtain the software, or access more of these tutorials, please go to the website fchartsoftware.com. These tutorials are excerpted from the book Mastering EASE, which can also be obtained from the F-Chart software website.